Welcome to a new lesson. Reasoning to solve problems. Let's first investigate this problem. Suppose that you are lost in the woods for hours and come upon a cabin. In the cabin you find a lantern, a candle, a wood stove with wood in it, and a match. What do you light first? And the answer is, you probably want to light the match. The next thing, what would you light? Probably a candle. After the candle, you'll probably want to light the lantern so you could see. And probably after the lantern, you probably wood stove. And the reason for this is because in order for you to light a wood stove, you might want to be safe than sorry, because if you have one match and that doesn't work, well, then you can't light anything else. As long as the candle is lit, as the lantern is lit, as you could see, you don't need a match to light the stove at all. Let's take a look at a little bit more harder investigation. In this investigation, we have Emma was given this math trick. Choose a number, multiply by 6, add 4, divide by 2, and subtract by 2. So come up with a conjecture and prove it using inductive and deductive reasoning. Now, we're going to use this inductive reasoning first to come up with some kind of conjecture. Then we're going to use deductive reasoning to prove if it works for all cases. So choose a number. Let's say I'll choose 10. Multiply by 6, and we'll get 60. Then add 4, we'll get 64. Divide by 2, that's 32. And subtract by 2. Subtract by 2, we'll get 30. Let's move on. How about choose a new number, which is 7. Multiply by 6, first, that's 42. Add 4, that's 46. Divide by 2, that is 23. Subtract by 2, you get 21. Now I'm going to use a negative value, just for fun. How about negative 3? Multiply by 6, we'll get a negative 18. We'll add 4, and we'll get negative 14. Divide by 2, we'll get negative 7. Subtract 2, we'll get negative 9. So we've done inductive reasoning, right here, inductive. And from this inductive reasoning, can we come up with a conjecture? So let's find the relationship between this 10 and the 30, as well as 7 and 21, and this negative 3 and negative 9. Notice that if we multiply our original number by 3, 10 times 3 is 30. 10 times 3 is 30. And then we'll do the same thing with 7 times 3 is 21. And negative 3 times 3 is negative 9. So whatever number we choose, as long as we multiply by 3, will be the same result as with this math trick. Now, inductive reasoning tells us that it only works for these 3 specific cases, but it doesn't work for all the cases. So how about we try to use deductive reasoning to find out that it works for all numbers, all cases. So instead of having a number that we pick a variable, and let's pick x. We will first multiply this by 6, then we add the whole thing 4. The whole thing then is going to be divided by 2, then subtracted by 2. So let us simplify this expression. we'll get 6x plus 4 divided by 2 minus 2. If we simplify this further, we have to divide 6 by 2, which is 3x. 4 divided by 2 is positive 2, and subtract negative 2. The result is we get 3x. Now we get 3 times the original value, and our original value was x. So this deductive reasoning shows us that it doesn't matter which number we would choose, we will always get 3 times the number we've chosen. Let's take a look at the first example. The members of our recently selected varsity basketball team met each other at their first team meeting. Each person shook the hand of every other person. The team had 12 players and 2 coaches. How many handshakes were exchanged? So this is a little bit tough problem, but let's first find out how many players there are. Well, if there's 12 players and 2 coaches, there are a total of 14 players. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14 players. So let's talk about the handshake. Let's say you were the first player and you would have to handshake each and every other player in the team. How many handshakes would you make? And the answer is 13. You would have to shake everybody's hand except your own. So 13. So we even made all the handshakes. What about the next player? Well, that person can count himself, and that person cannot count you because that handshake has already occurred. How many handshakes does that person have to make? Well, it has to be 1 less. Then this pattern continues. The next person has to make 11 handshakes. The next person 10, 9, 8, 7, 6, 5, 4, 3, 2, and the last 2 people will have to make 1 handshake together. If you add them up, you would get 91 handshakes. Let's take a look at one more example. Sue signed up for games at her school's fun night. 7 other people were assigned to her group, making up 4 pairs of partners. The other members of her group were Dave, Angie, Josh, Tanya, Joy, Stu, and Linus. When the game started, Dave and his partner were to the left of Stu. Across from Dave was Sue, who was to the right of Josh. Dave's brother's partner, Tanya, was across from Stu, and Joy was not on Stu's right. Name the 4 pairs of partners. When it comes to word problems like this, it is probably a good idea to read the question one more time to yourself, and then draw a picture. So, in this case, we're going to draw a table, and we're going to have a list of all the names to the left-hand side. And we're going to cross them off as we go along. So we're going to start off. When the game started, Dave and his partner was to the left of Stu. So if Stu was right here, Dave was to the left of Stu. So we have Dave and we have Stu then. From across from Dave, that means on the other side, was Sue, who was to the right of Josh. Now, that means Josh had to be a partner with Stu, because Sue was to the right of Josh. There you go. So we have Josh crossing off, and we have Sue crossed off. Dave's brother's partner, Tanya, so So Dave's brother's partner. Well, we don't know who Dave's brother is. Tanya was across from Stu. So where is Stu? So we know that Tanya has to be was across from Stu. So here's Tanya. And Joy was not on Stu's right. Well, that one I'm not sure about, but let's talk about that sentence. Dave's brother's partner is Tanya. Well, Tanya has a male partner, and the only name that is male, it's not Angie, it's not Joy, it's Linus. So Tanya has to be partnered with Linus, who's a male name. So Linus is done. And it says, so we're looking for Dave and Sue, partners. So Joy was not on Stu's right. So Joy was not on Stu's right. If Joy was not on Stu's right, she has to be on left or across. But since Tanya and Linus are partners together, Joy has to be on Dave's side. And since Angie's only left, Angie is with Sue. And here are the 4 pairs of partners. Linus and Tanya, Sue and Angie, Stu and Josh, Dave and Joy.